Now, when we sit down to eat, we rarely consider how truly valuable the food in front of us is. In fact, the arable land in hectares per person has been steadily decreasing since the 1960s. And recently, during the 2010s, agricultural output slowed down. So it is imperative, if we are to sustain ourselves, that every piece of arable land be as productive as possible. And then we have been trying to achieve this with chemical pesticides and fertilizers, although these cause problems of their own. The World Health Organization has expressed various concerns about the exposure to humans and say that this causes acute and chronic toxicities and could cause contamination of soil and water. Not only this, but chemicals cause headaches for the very industry they're trying to help. Farmers cannot harvest their crops immediately. They have to wait a long amount of time from product application to harvest. The canisters in which the chemicals come in need to be returned to the manufacturer, and pests can always develop resistance to these chemicals. But the reason why they're still being used is because they're extremely cheap. So what would be here the ideal solution for the agricultural industry? Well, biofertilizers and biopesticides, which do not exhibit any of these problems, that would be as cost effective as chemicals. Sounds like a very difficult thing to achieve. Well, here's where we come in. You see, our lab has extensive expertise when it comes to endophytic entomopathogenic fungi. Now, these are fungi that normally, naturally, infect insects and kill them. Now, these fungi also inhabit the cells of plants. Recently, our laboratory has isolated for the first time an indigenous fungal strain with some unique properties. Now, we have combined this strain with a formulation of our own design, and we have created TriPhyte, an agricultural bioproduct that acts in three ways. It acts as a biostimulant and a biofertilizer by regulating the metabolism of the plant, and it also acts as a biocontrol agent against insects and fungi by boosting the immune system of the plant. Now, let's talk a bit about how we produce TriPhyte. We use a packed bed bioreactor, which is a solid bioreactor. This is where we cultivate the fungus. From there, we extract the spores and apply the formulation, in which case we produce TriPhyte, the product, which is granular, and this is then packaged and sent to distributors. Now, the important thing here to note is that our cost to produce TriPhyte is estimated and valued at 45 euros per hectare per crop. Now, our excitement for this project comes from the results of our field trials. We have performed field trials on potatoes, which is a primary crop cultivated in the EU, and its main pest is the click beetle family, which is especially dangerous in its larval stage, where you can see it here as a worm. Now, our results, on the right, we see the results of TriPhyte as a biofertilizer, where it has achieved a 20% total yield increase. And in the middle, these two photographs show its action as a biopesticide. At the top, we have a potato where our product has not been applied. You can see here that the potato is infected with beetles, the worms. So this is a potato a farmer would have to throw away. Now at the bottom is a potato that has had our product applied to it. This is a perfectly healthy potato that a farmer can sell. Now, let's look a bit about our market. TriPhyte is a product for farmers and small-scale growers that use chemical products. So our market is the global fertilizer, insecticide, and fungicide market, which is currently dominated by traditional chemical solutions, but you can see here that biological solutions are a 1% and a 10% of the market in total. And this is steadily growing. Now, our competition is extremely fierce. There are a lot of well-recognized companies in these fields with well-established products. but we believe that our product has several advantages. These competitive advantages include the fact that this is an all-in-one product. So this is a product that acts both as a biofertilizer, a biostimulant, and a biopesticide. So a farmer would only need to buy a single product in comparison to 3 products. It also requires a single application per crop. And because of this, and the fact that pests cannot develop a resistance to this, we require no pesticide rotation. For the farmer, this effectively means half the cost. Now, the road ahead is divided into 3 phases. By the end of this year, we will have applied for a patent. By the end of the next year, we will have our final product formula. And in the next 2 years, we will have applied for US first and then EU approval. We expect to enter the market in 2028, the US market first. Now, let's look a bit about our financials. As we've said, 5 years from now in 2028, we expect market entry in the US market first, and we expect to make our money back between the 5th and 6th year from market entry, so 10 to 11 years from today. Now, the team that's going to be tackling this project is our team. We are all biologists from the National Catholic University of Athens, and between us, we have more than 10 years of experience in fungal genetics and biotechnology. I don't know if I've been able to convey how excited we are for this project, because we believe that this is our chance to feed the world. But this time, do it right. Thank you very much for your attention, and we are available for any questions you may have.